Hello there. In this video, we're going to do reneging in the Ciw Python package. So reneging is basically that you've got a customer waiting on a queue, and after some amount of time, they either get service, which depends on how much time they're actually waiting for the others that are getting service in front of them to finish service so that there's space filled up for them, or they renege, meaning they were waiting, but after some amount of time, they decide they're leaving, or that something happens that forces them to leave. So reneging works in Ciw on the basis of a time to event distribution that you can sample when they enter the waitlist. Let's check it out. So we can go import Ciw, and we'll jump right into using the create network function, because really you don't have to define anything other than an already supported distribution, or you can create your own distribution, which we've covered in previous videos. So let's go with something simple here. We've got an exponential with maybe a rate of, well, sure, 5. Why not? And then let's also do service distribution, of course. We got to always put in these required ones. And then number of servers, we're just going to do a single node. So just one, let's say, single server, single node. And now we're finally at the part where we can put something new in. It is the reneging time distributions. There's going to be one for each node. And there we can pass in this list, and we can choose whatever we like. So in this case, let's maybe do deterministic of 6. Notice that, we'll go 2. Notice that, I mean, they come in at a rate of 5, which is greater than the rate that service is completed at. So you know there's going to be some waiting going on. And if you think about the utilization coefficient row, that it should be the case that you're actually going to get reneging accumulating. And so if they don't get their service within this amount of time, that will mean that they just start leaving. So in a weird way, this can create like queue waiting length stability, but you got to watch out, because are your waiting times stabilizing because people are actually just leaving? That's not necessarily desirable. You want to kind of know at the same time they're getting maybe the service that they need or want. Okay, that's actually it. I mean, we can maybe, for the sake of example, let's run a quick simulation if name is equal to dundermain. We could set, of course, our seed number. And spelling does count in programming, so dundername needs to be spelled correctly, oddly enough. And let's go q.simulation to create our simulation instance. Pass in our network for the network parameter. What's next? All right, so we got to run the simulation. Naturally enough, it's not called run. Simulate until, and here we'll do max time. It's kind of unfortunate in the design that like the most plausible amount of time, plausible option for running the simulation actually requires that you type it out to get the right autocomplete, but oh well. And I don't know, the example in the documentation, I don't know why they're mixing and matching stuff. They say we could put exact to keep track of like exact times. But you know what? I don't think we really need to do that right now. Interesting, the documentation has 5, and technically 5 is a truthy value. That's why I'm getting the complaint of this literal type 5. But yeah, anyway, anything that's truthy for true should do the work, do the trick there, but we're actually going to skip what the documentation asks, because we don't actually need it. I'm not sure why it's in this example. So records, we can go simulation.get all records. And here maybe we want to look at a combination of how many completion records or like service records there were versus reneging. So we could do, what is that argument called? Only. Grab only. And we'll grab service. meaning completed services. And we'll also grab reneg, which is really what we're talking about. Reneg. Renege? I only hear it called reneg. Okay, so records. So we selected out some records. We might let's just run it. So how to simulate reneging customers. All right, so that runs. Maybe we should print out our something about our records. Maybe let's, as per the docs, we'll calculate the maximum of, sure, let's say record dot waiting time for record in records. Now the records are already filtered down to 2 types, but in this case we might actually want to get more specific to get maybe the maximum when the record type was service specifically. So if record dot record type equals service, should do the trick, although we'll probably want to print this just to look at something. And then let's do the same for reneging. So you can see that the waiting times for reneging are perfectly exactly 6 because we had in the, as per the example, set up this, we had set up that deterministic amount of time here, right? Deterministic of 6, and that's why we get 6 for the maximum reneging time, but also the min would be the same as well because they're all 6. But when you're looking at the maximum service time that wasn't reneged, the service times must be strictly less than 6, right? The way the simulation is set up, this wouldn't even necessarily be a bad thing to assert, actually. It's a matter of, you know, checking that your simulation actually does what you think it did type of discussion. This is definitely not easy to read code, but good. Like that. Oh, wait, we just did the bool. We want to do an assertion. There we go. And the assertion. Oh, actually, I didn't save, and that definitely would have been a bug. There we go. Now it's saved and run with the assertion in it, that you can see that that is the case. It will, of course, should always be the case. Like even if I get rid of the seed number and I run it a few times, it really should never error. And then I say that, and then it did it. Oh, because it's empty. So that is actually a possibility, and that's also sometimes why testing things out really matters, because I didn't think about the condition of, you know, what if one of them is actually empty? Then the comparison's not defined anymore. So anyway, hopefully that's useful. I think that there are a lot of types of systems out there where you get reneging, where basically for one reason or another, customers, patients, packets, whatever, are lost while they're actually waiting. Doesn't tend to happen too much with like job queues, because you are, well, actually it can in certain circumstances. Anyway, maybe not get into all of the nitty gritty, but the point is that in many systems, reneging is a thing. Reneging is just when, after some amount of time, a customer or whatever will leave the queue and go elsewhere, possibly just out of the system or elsewhere. So let me see, what else is there I can say at the end of this? You can have, when you're doing like multi-classing networks, you can have different distributions so that different types of classes of customer or patient or whatever will leave after some amount of time. Now, by default, when they renege, they leave the network. Maybe in another video, we'll cover how you can get them to go elsewhere. But for now, that's probably a good place to stop. So with that, enjoy the rest of your day. Take care.